welcome back. It must have been 4 or 5 months ago or so, we were working on an old Hewlett-Packard 521A all vacuum tube frequency counter. It's a really cool piece of equipment, and we got it really close. It's mostly working, but we still had some issues to figure out. But I haven't touched it for a very long time, and I have a pretty good reason, I think. Shortly after I finished filming the last episode in this repair series, I had to take all of my HP equipment and haul it outside because I had some extended family coming to visit and they needed to stay in this room because even though this is the room that I film in, it's also actually the guest room. I don't have a dedicated studio. So I took all of my HP equipment outside, put it in our little office in the garage, and locked it up for 3-4 days while extended family was here. And then almost 2 days immediately after our extended family went home, I was getting all geared up to pull the HP equipment out, and well, this little guy showed up. Say hi, Sue. This is our little boy named Sue. And well, he didn't just show up by himself. He brought his 2 sisters with him. That is June and Tin. They're actually all 3 here in the room. The other 2 are just playing over by the Centurion. And well, we had to find a place to put them because when we got them, little Sue here was less than 300 grams. They were all way too small to be separated from their mama. And so we turned the office that I had all of my HP gear stuffed into a sort of cat nursery. And that was where we took care of them until they were big enough to start living outside. Now they still sleep in the office at night, but throughout most of the day, they're outside playing around, having fun. And what that meant is that I could finally get into the office and get my HP gear back out. So that's what I did. I've got my HP gear out, and it's time to get back to work on the 521A. So little Sue here is going to keep me company. Let's hop over to the bench. We'll take a look at what's still wrong with it, and then hopefully we'll get it fixed and working in today's episode. So say hi to everybody, Sue. All right, let's go get to work. All right, to show exactly where we are with the 521A, I've got my 200 CD wide range oscillator out, and I have it set to 6 hertz. So we should only be seeing something in the first column here, and well, that's right. And you can see it's counting up to 5, not quite 6. I might just have to tweak this a little bit. Yeah, there we go, that's 6. This first column seems to be working just fine. As a matter of fact, if I go up to 10 hertz, we should see it spill over to the second column here. Yeah, there we go. So we're seeing 11, 12 hertz here. So that seems to be working really well. And actually the second column is working perfectly as well. So if I change this over to times 10, that's now 100 hertz. And you can see that that's counting correctly. It's actually counting up to 119 hertz or 118 hertz. Except now we've come across our first problem. The third column here has some neons that are not illuminating. The number 1 is not illuminating, but 0 is. So it's resetting to 0 correctly, but we have some neons that aren't working correctly. And if we speed up even more, if we go up to say like 600 hertz here, we can really see that it skips 1 and 3 when it counts. And well, but we get 4, 5, and 6. So I don't know, there's something wrong in here. It could be individual neons, or it could be part of the actual whole circuit that causes these to illuminate. However, it does seem to be counting correctly. But if we get even faster, we're going to see we've got some serious problems in the fourth column here. So right now we're at 1 kilohertz. So it should say 1000, and it looks like we count up past 9. 9 doesn't illuminate, but we're never coming off of the number 4 on this one here. And not only that, the 4 is really dim. So let's go even faster. Let's go up to say 5 kilohertz here. So we can see it looks like it's trying to count correctly. It just, for some reason, it seems to think that the number 4 is the number 0. So it resets to 4. If we get even faster here to about 9 kilohertz, then we run into an interesting problem up top. We can see it doesn't count in order. It skips the number 6, goes straight up to 8, then drops to 7, then bumps up to 9, So we've got all sorts of weird issues going on with this column. And I have pulled the individual decade counters here out and switched them around, and the problem follows the decade counter. So the unit itself is fine, we just have an issue with these two decade counters. So what we're going to do is we're going to pull these out and figure out what's going on. Initially, I had thought that some of the resistors might have drifted too far out of spec, so I started measuring the value of each resistor in circuit. But of course, whenever you measure the value of resistors in circuit, you're going to get a value that is wildly different than what the resistor indicates, because there are a ton of other things in parallel to that resistor, and that is particularly true in this circuit. However, I have 4 of these decade counters that are all identical. So I can measure, say, R32 in one of these decade counters and then cross-reference it against the rest of the decade counters to see if that parallel circuit has drifted too far. However, they all measured out pretty much totally fine. And really, the more I thought about it while I was sitting there measuring resistors, the more I realized it had to be janky neon bulbs. We had so much trouble with these in the previous episodes. They are extremely corroded, and even though some of these look like they're working fine, the corrosion is so severe that I think it might be causing additional resistance to show up in the wire that shouldn't be there, and that could be pushing things out of spec. Now, the reason that I only replaced a select few neons before is because I was using old neons that I had salvaged out of some older Tektronix equipment. But while I was digging through the manual, I looked up the spec for these neons, and they have a 90-volt ignition voltage. And it turns out that about a year or so ago, I bought 100 neons on Amazon, and they're also a 90-volt ignition voltage, which means that these should work perfectly. So the next step was to desolder the suspect neons and solder in some of these new ones, even though they're much smaller, and then give it a test. And yeah, sure enough, it seems to be working correctly now. So that's one decade counter working. The next one is the one that had multiple neons that weren't illuminating, and looking at it, these are very crusty and bad, and so I'm just going to replace them all. I'm going to rip all the old neons out, solder in all of these new neons, and if this works correctly, that bodes well for the rest of the decade counters. So now that we've got them all soldered up, we'll toss it back into the machine, and yeah, there we go. That seems to be working perfectly. All right, so I'm not usually a fan of doing blanket replacements of all of one type of component, but man, these neons are all so crusty, and so I'm gonna go through and replace every single neon on all 4 decade counters. All right, with all of the neons replaced in all 4 decade counters, let's give it a test and make sure at least that all of the neons are illuminating and they're illuminating in the correct order. So we'll flip the power on. I actually had this flipped on before I turned the camera on to get the tubes nice and warm, so we didn't have to sit here and wait for 2 minutes for everything to warm up. The 200 CD oscillator, it's on and warmed up, and it's sitting at an indicated 5 hertz. Now this is set to 1 second, so it should just count from 0 to 5, and well, it's counting up to 6, but what's important here is that I see it go 0, 1, 2, 3, 4, 5, 6 in perfect order. Now what I want to do is I want to make sure that everything is cascading correctly. So instead of having the gate selector at 1 second, I'm just going to flip it over to manual here. We'll turn that off, hit reset, make sure that everything's at 0, so that's good. Before, when I was hitting reset, one of these was resetting to 4, but now everything's resetting to 0. That's good. So we'll set our manual gate to count here, and that's just going to cause it to count without stopping. So there we go, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then, yeah, it's cascading correctly. So we've got 1, 2, 3 now. So we'll go ahead and speed this up a little bit here. There's 5, 6, 7, 8, 9, and there's 100. So this counted from 0 to 9 perfectly, and in our hundredths digit, it looks like we cascaded over and we're counting up correctly on it. So we'll go faster to get the rest of the hundreds digit here. So we had 9, we're going to cascade over to the thousands digit, and yeah, there we go. We went to 0 and 1. So we'll slow it back down here, and we'll bump up to a times 10 multiplier on our oscillator here. And so we'll go even faster now. There's 2, 3, 4, 5, 6, 7, 8, 9, and it all resets. So everything is counting and cascading perfectly. That is awesome. All right, so now we're at times 100 with the indicator set to 10. So that should be 1 kilohertz. So if I drop this down to 1 second here, there we go. It's showing a little more than 1 kilohertz. It's showing 1,175, 76 hertz. That could be that this is out of alignment or this is out of alignment. But the 521A is pretty easy to get into alignment because it has a self-check mode. So we'll just rotate the input sensitivity all the way over to the left here to check, and we should see 60 hertz. Now we're getting 72 hertz. And I'm pretty sure that my line voltage coming out of the wall is not at 72 hertz. So we need to do some adjustments. So it's time to pull out the manual and get the 521A adjusted according to the manual. And the first step is to check that our power supply is putting out 200 volts. And there's a big potentiometer right here to adjust that. So the manual says to attach a voltmeter to pin 3 of V6, and this is V6 right here, and pin 3 is just the same pin that this replacement capacitor is on right there. So that should tell us if we're up to the correct voltage. So we'll go ahead and flip the power on here. There we go. It took a little bit for everything to warm up and for the voltage to stabilize, but it looks like it's stabilized at 203.4 volts, which is probably totally fine. It's just slightly high. So we'll give this potentiometer a little twist here and see if we can get it down to 200 volts exactly. Right there, 200.2 volts. That should be our power supply adjusted perfectly. The next step is to adjust the Phantastron frequency dividers. The frequency divider adjustment is done in 2 different adjustments. The first is to set the input sensitivity here to check, which is already in, and then it says to set it to 1/10 of a second. And so that's going to keep the first 3 rows here displaying 0, and then the 4th row is going to be showing 6 for 60 hertz. And actually, that's consistently correct at 60 hertz. So I don't think we actually need to adjust that one. So we'll go back up to 1 second, and now it should be consistently displaying 0060, but we can see that it's displaying 0072. So we have an adjustment here. So here are the 2 adjustments on the back of the machine. This is the 0.1 second adjustment that we would have had to adjust if when we were in 1/10 of a second it wasn't showing 0006. This is the 1 second adjustment, so this is the one that we're going to have to adjust next. It has a little locking nut on there, so we'll go ahead and just snap that loose. There we go. And then we just twist this potentiometer to bring it into spec so it's showing 0060. And that looks like it. It's showing 0060 on the front perfectly. So we'll go ahead and tighten up the locking adjuster here. Yeah, perfect. All right, the next adjustment that I wanted to do was the amplitude discriminator sensitivity adjustment. And so this one says to connect a 1 kilohertz input signal of about 3 volt RMS amplitude to the input jack. So I pulled out my big HP150A here because the calibrator on it should be 1 kilohertz. Now it doesn't have 3 volt RMS. 3 volt RMS is about 8.5 volts peak to peak. The closest I had was 10 volts peak to peak, but you know, importantly it says about 3 volt RMS, so you know, that's fine. But this should be pretty much exactly 1 kilohertz. And if I get my horizontal position adjusted correctly here, it sure looks like it's 2 divisions from rising edge to rising edge, and at 0.5 milliseconds that should be 1 kilohertz. But when I connected it up to here, I'm getting 959 hertz. It's not quite 1 kilohertz. So before I started doing all sorts of adjustment on this, I started to actually doubt whether this was putting out exactly 1 kilohertz. Now the calibrator is not adjustable, so I pulled out my modern Siglent scope here, and you can see it's reading the exact same square wave off the calibrator, and it is showing 957.9 hertz. And that's exactly what this is showing, 957 to 958. It's like it knows it's in between 57 and 58 hertz. That is bang on, perfectly accurate. That's insane. So with the combination of these 2 pieces of equipment, we're golden. Except we have one more adjustment that I want to make, and that's for the crystal time base. So everything that we've been testing up to now uses the 60 hertz that's coming in from the mains AC as a time base for all of the calculations to show us the frequency. And that seems to be working perfectly now, which is excellent. But if you have unstable mains, or for whatever reason you need more or better precision, this crystal controlled time base here was an option. And you can switch between the 2 using this little switch right here. Right now I've got it set to line external, but if I flip it over to the left, that changes us to the crystal. So now that we're on the crystal, we can essentially do a self-check. So we'll switch this over to 1/10 of a second. We'll bring our input and sensitivity all the way down to check, and it should show 1000. And it doesn't. It shows 990. And if we go to 1 second, it now should show 0. So it should essentially go through a full 9,999 and come back to 0, but it doesn't. It goes to what appears to be 1,890. So our crystal-based oscillator is a little inaccurate, so we got to do some adjustment on it. All right, so we'll just go down the list here. It says to set the time base selector switch to line or external, so we'll just flip that one. We want to self-check it, so we'll put it in check 1 second. Let's make sure that it still says 0060. Yeah, it does, 0060, that's perfect. All right, so now it says to connect the jumper lead from the 10 kilocycle output pin 6 on the socket to the input jack. So we'll go ahead and just connect up a little connector there. And then it's actually marked 10 kc up here on the socket, and that is gonna be this pin right there. All right, it says turn the input sensitivity control to maximum clockwise. Turn the gate selector to 1/10 of a second, and the display count should be 1000, which it is. We've got 1000. Oh, did you see that? It said 1001 there for a second. Yeah, there it goes again, 1001. So it seems like it's right on the edge. So let's go ahead and loosen up the lock nut here, and we'll see if we can just maybe twist that a little bit to see if we can get it a little closer. So we'll go clockwise first, see if we can get it to do 1001 consistently. Nope. All right, so let's go to counterclockwise. Oh, there we go. Yeah, we're up to like 1250. So there's 1001, there's 1000, and then that bottoms out the potentiometer. Ooh, that's probably not good. We're kind of at the limit of what that potentiometer can do. So we'll just kind of get it as close as we can, I guess. All right, well, that's not ideal. The potentiometer pretty much bottoms out completely, and we're still getting 1001. I don't know if that's going to cascade and cause all sorts of problems further down the line, but we can check by just moving it to the next lower output frequency, which is the next step in the instructions here. So we'll go to pin 7. So we will very carefully disconnect it from there, connect it up to there. That should be pin 7. And then it says it should be 0100 on the 1/10 second gate or 1000 on the 1 second gate. Well, and there we go. It's 0100. That looks pretty bang on, but I did see a 0101 in there on the occasion. Let's flip it to the 1 second gate and see what happens. Yeah, 1001, 1000, there we go. All right, again, not exactly ideal that we're sometimes getting 1001, although it looks like we're getting pretty consistently 1000 now. Well, we got 999. Yeah, well, I'm curious if this potentiometer is bottomed out as well. So we'll go ahead and loosen it up. And then we will just give it a bit of a twist here. Well, we're not, oh yeah, that one's pretty much bottomed out as well. Yeah, bottoming it out takes us down to 999, 1000 sometimes. If I go the other direction, we get, should get much higher numbers. Yeah, 1005. 1,230. All right, so we'll bottom it out, and then we'll come just a little bit off of the bottom there, and we should see pretty consistently 1,000. Well, I think 1,000 or 999 is gonna have to be our sweet spot. All right, just one more check. It says go to the 100 CPS output, which is pin 8, which is gonna be that little blue wire right there. And again, the displayed count should be 0100 on the 1 second selection. All right, now this one looks to be pretty consistently showing 111, or sometimes I see 112. So this one, yeah, there we go. So this one definitely needs adjustment. So we will loosen up the little lock nut here. We'll give it a little twist. See if we can get that to show 0100. Yeah, look at that. 0100, that's perfect. And this one has a lot more leeway in it. It didn't feel to be on the stop. Yeah, there we go, that's perfect. All right, so the next step is to change it. We'll disconnect our little lead here, and then we change it back to self-check, change it over to XTAL, and we're on the 1 second gate, so it should be 000. Yeah! Look at that, all zeros. That's perfect. Okay, so we'll go to the 1/10 gate, and it should be 1000. Yeah, yeah! Yeah, 1000, that's perfect. We got it perfectly adjusted. There we go, I've got the case back on it, and it's looking beautiful right here in the trio of completed HP equipment that we have. And well, right now I've got the 200 CD oscillator outputting a sine wave on the scope here. We can see that that sine wave is 1, 2, 3, 4 volts peak to peak. And it looks like it should be about a 1 kilohertz sine wave. But if we look over here, we can see it's exactly 1003 hertz. And since this thing is totally adjusted perfectly, I trust it. I believe it. It's exactly 1003 hertz. That's just so cool. Oh man, I'm so excited that I decided to finally pull this out of the garage and get to work on it. It's working beautifully well. Let's speed the sine wave up just to see what happens. So we'll go up to times 1000 here, and we'll drop it to about, oh, I don't know, 7 kilohertz. We can see that, yeah, we're definitely a lot faster now. We'll bring our sweep time up so we get a better look at the sine wave. And yeah, if we look at this, it's showing 6,908 hertz. There we go, just a little bit adjusting, and I got it up to 7,013 hertz. That is, oh man, that's just, I'm kind of laughing, and I don't really know what to say, because this has been a project that's just been sitting in the backlog forever, and to get it out and find out what was wrong with it and fix it and get it working perfectly alongside these other two is just this achievement that feels amazing. And just the feeling of being able to put a stamp on this that says done, this project is now finished, just feels awesome. But also, I have a beautifully working 521A frequency counter. Just 2 years ago, I would have thought this was unobtainable, but through sheer luck and talking to the right people, I got it. It needed a bit of work, but now it's up and working. This This is awesome. I am just over the moon with how all of this is starting to turn out. But there is a lot more HP equipment that needs work. Most notably, I have 2 vacuum tube voltmeters that I really need to get going. So if you enjoy seeing old HP equipment come back to life, hang around. We've got a lot more to come. So I want to thank you guys so much for watching and holding on while there was like a 2 to 3 month break in between part 2 and part 3 of this series. But thank you so much for hanging out with me while I work on my old HP stuff, and I hope to see you in the next episode.